In this video, let's talk about practice quiz 13 on trigonometry. So number 1 says convert the given degree measure to radians for part A. So I'm going to take 144 degrees and multiply by the conversion of pi over 180. And then I am just going to work on reducing that number with my calculator. So when you reduce it and you want to leave it in radians, a lot of times they'll leave the pi and just reduce the fraction. So if I put this together, I have 144 over 180 with pi in my numerator. So I just want to type those numbers without pi. And then 0.8, if I want a fraction, I can hit math, enter, and get a fraction. So it will be 4 pi over 5 radians. For part B, I want to convert the given radian measure to degrees. So I just need to go the opposite way and multiply by 180 divided by pi. I always remember that if I want to get rid of the pi to put it into degrees, I need to put them diagonal from one another so that way they cancel each other out. So that helps me remember which way to write it. And then I just bring over 3 times 180, which I believe is 540. Yeah, 540 degrees. Okay, for the second part of this question, it says find the length of an arc of a circle with a radius of 10 meters that subtends a central angle of pi radians. So we need to use our arc length formula with a central angle that's in radians. So remember, S equals R times theta. S is our arc length. R is the radius. And then theta is the central angle in radians. So it says find the length of an arc of a circle with a radius of 10, so that's our radius, and that subtends a central angle of pi over 6, so that is the theta that they've given us. So all you have to do is plug those in. So S equals 10 times pi over 6, and then just reduce that. So we have 10 pi over 6. We can divide those by 2, and we would get 5 pi over 3 for the arc length. And that's it for number 1. Number 2 says find a positive and negative coterminal angle to an angle that measures 158. So a positive coterminal angle is found by adding 360 degrees. So 158 plus 360 is 518. And if needed, you could do that more than once on a question. But we already have a positive number once we add 360, so we don't need to add it again for this one. That would be enough. And then 158 minus 360 would help us find a negative coterminal angle. And again, if you needed to do it more than once, subtract 360, that is, you could do it more than once. Okay, so we get negative 202 degrees for the negative coterminal angle. Then find the reference angle for each of the following. So 300 degrees. I'm going to sketch 300 degrees because I like to see it. So 300 degrees goes in the positive direction. So starting in standard position, I would go in the positive direction, but then not quite all the way around the circle. So you want to think of what is the closest distance to get back to the x-axis from that terminal side. And that would just be that leftover 60 degrees. So my reference angle for 300 would be 60. Then let's sketch out negative 195 degrees. So negative 195 starts in standard position and goes around, and it goes a little past 180 because it's negative 195. So then the closest distance back to the x-axis would just be how much further it went past 180. So that was just 15 degrees right there. So that is the reference angle for negative 195. And that's it for number 2. And let's see, that'll be also number 3. So I'm just going to change that to be a number 3 right there. Number 4 says graph one cycle of the following function. Y equals 4 sine of x minus 1. So what we can do is type this into Desmos. Let me grab Desmos to help me out. And I'm going to type in just like it looks. So 4, you can type sine on your keyboard, or you can use the Desmos menu to grab it from your functions menu in there. And then minus 1. But then I just want one cycle, meaning like from 0 to 2 pi. So in my wrench, I'm going to change it from 0 to 2 pi because I just want to see that one completed cycle. And then I'm just going to also graph my midline, because that's going to help me click on some good points. So y equals -1 is the midline. That helps me sketch this. So I'm going to sketch a little dash line at -1. And then click on these tick marks to help me get 5 good points to graph. So I've got 0, -1 is my first point. And then the next good spot would be pi over 2 goes with 3. So go up to 3 and put a dot at pi over 2, 3. Then pi is right there on my midline. So not the x-axis, but the midline, because that's where this is centered around. Then 3 pi over 2 is going to be what was that, -5. So let's go down. This is 1, 2, 3. This is -1, -2, -3, -4, -5. So I just need that dot. And then I need to come back up to 0, or excuse me, -1, because that's my midline, which would normally be 0, but it shifted down. So that's why it's at -1. Then you just want to sketch as best you can that S shape. Since it's a sine graph, it looks like an S. But like I say, Desmos is very helpful, and you can just make your window match. So like go to the wrench is what I call that little tool in the corner. And you just had to put X was from 0 to 2 pi, and it makes a really nice view of your graph. And then I drew the midline in green. So my midline helped me out too. I graphed my midline, which always goes with your vertical shift. So that was at -1. And that helps you get a really nice graph out of Desmos. All right, the last question says, given y equals -2 cosine 4x minus 5. State the key features of the graph. So my amplitude is always positive, and it's like the vertical stretch or compression value. So that is just 2. You can pick it right out of the front. The midline goes with the vertical shift, so that would just be directly related to that -5. It makes it go down 5, which I'll write down in a minute with my transformations. So y equals -5 is the midline. You want to write it as a line. And then the period comes from 2 pi. The formula is period is 2 pi divided by b. B is always your frequency, which is squeezed in between the cosine or the sine and your x or whatever variable they're using. So in this case, my frequency was 4. So I just need to do 2 pi divided by 4, which is pi over 2. So now let's take the transformations. They work like any other function we have talked about so far. So the negative is going to make this function reflect over the x-axis. Let's start with that. The 2, which was my amplitude, makes it have a vertical stretch by a factor of 2. And we don't talk about the frequency because that's just not included in our Math 3 standards. So then we're going to write out that it went down 5. I'm not trying to change colors, so I was skipping back to purple. Okay, so it shifted down 5 was the other transformation, and that was a vertical shift. So let's write that as well. All right, so that is it for practice quiz number 13.